Hi students, welcome to Alpha's e-learning program mathematics class. We are in trigonometry periodicity concept and we have done some concepts already. Basing on those concepts, now today we are going to do some more problems. Now students, actually we have observed is in previous session the last concept, that one is nothing but here LCM of real numbers. Now LCM of numbers, whenever you observe, students, you observe this is suppose the LCM of fractions you are getting, that means a by b comma c by d comma e by f, okay, and suppose you want LCM of these numbers, then we have observed that this LCM is nothing but you can remember as LCM of the numerator values and divided by the greatest common divisor of the denominator values. Directly you can write this is nothing but here LCM of these numbers. For example, if I take this is LCM of, we want 1 comma 1 by 2 comma 1 by 3 comma 1 by 4 1 by 5 etc. 1 by n. Understand, all are here denominator values are integers. 1 means it is nothing but 1 divided by 1. Then what about here LCM of this kind of value? So you can say clearly basing on this concept, numerator all are here 1, therefore LCM of numerator is here 1. Then what about here greatest common divisor of 1, 2, 3, 4, 5 etc. up to n? It is obviously how much the value is 1 itself. Therefore 1 divided by 1, and hence what about here LCM of this kind of values? It is 1. And even if I take suppose LCM of only 1 comma 1 by 2 comma 1 by 3, then also LCM is 1. And if you take 1 by 4, then also LCM is 1. Like that, if you take finite number of values in this model, then the LCM is nothing but how much? 1. Now let's have a glance on these model problems here. Students, take this one. So LCM conditions, rules and regulations all we have discussed in previous session. Now based on those we are going to solve these problems. The problem is this entire value given as here f of x, right? Tan pi x plus tan 2 pi x plus tan 3 pi x etc. So this entire thing is now our f of x. They are asking what is period of f of x. Then to make use of this one concept we have discussed, that is whenever linear combination of terms exists, that is c1 f1x plus c2 f2x, like this if it is given as linear combination and then denominator also you can write here in this way, then we can say the period of this entire thing is nothing but LCM of individual periods when they are periodic, okay? LCM of individual periods you have to consider here. So this concept, basing on this concept as well as the other one is once f of ax plus b period, suppose I require, then period of f of ax plus b is nothing but period of f of x divided by mod a. So basing on these two formulae we are going to find here this answer. Understand? So one is once the all functions are expressed as linear combination, plus symbol, or here it can be minus symbol, and the other one is this formula. So now observe students, what about tan pi x period? It is actually period of tan x divided by the x coefficient. Hence here period of this function is nothing but pi divided by pi. Okay, the x coefficient is here pi, therefore pi divided by pi. Now basing on this one. And next the other one is here the second function period. So for this one it is pi divided by 2 pi, okay, to this function. And like this here to this function if you take, it is pi divided by 3 pi. In this way etc. you can say here up to here pi divided by n pi, okay, basing on the formula f of ax plus b, everywhere coefficient of x here pi, here 2 pi and here 3 pi, like that it is n pi. Now if you cancel these values, it is nothing but period of the entire thing means what is the value you can obtain here? LCM of all individual periods. that is LCM of it is nothing but 1 comma 1 by 2, 1 by 3, etc. It is 1 by n. Now just now I told you about how to find LCM of these numbers. It is nothing but 1. Therefore period of the entire function is nothing but how much? It is 1. That means what actually we have proved, f of x is given some tan pi x plus etc. this entire value, understand? And now we have proved if you put x place x plus 1, replace x by x plus 1. That means tan of it is pi into x plus 1. Wherever x is there, just we are substituting here x plus 1. Then you got this value as tan. If you multiply inside pi x plus it is again pi. Like that everywhere you will get. Now if you apply allied angle concept, what will happen? Tan of pi plus pi x, 180 plus theta. This is 180 and this is your theta. Then the answer is again tan theta, because in third quadrant tan value positive. So you will get how much here? Tan pi x. Similarly other also implies you got how much here again? F of x. So the concept of periodicity, however we are using some formulae, but you have to understand they are basing on one and only one thing, that is f of x plus t equal to how much? It is equal to f of x. Then when t is positive, this t is said to be here period of the function. Understand? In that way we have taken x plus 1 and this is same as how much? F of x is f of x plus 1. So we decided 1 is here period. Similarly if you take 2, 3, 4 also you will get, because the least positive value we require, and that is nothing but here 1, which is known as fundamental period. So concept of periodicity, students, understand you are not simplifying the value, and this is whatever the answer you got 1, it is not the value of f of x. Understand? What we are doing, you are finding period of this function. That means you are not finding f of x value, you are finding period of f of x. So that period of f of x for this problem we got 1. Now let's have a glance on the other problem. Second problem, students, let us observe. That is period of sine 2 pi x, 2 times 2 pi x and minus 5 times cos 2x whole divided by the entire value. Okay, so for this problem, what about here? Period. And just now we have seen this problem where the all values are in numerator, then the concept we applied as LCM of all individual periods. Whereas to this also you have to use same concept, whether they are in denominator, whether they are in numerator, but same concept we can implement. Now what about here? That period of function. Again same thing, what are our functions? Individual functions. If you take f1x, suppose it is sine 2x, right? And next to f2x value, I am taking cos 2x. Don't bother about whatever other constants involved in the problem, plus 2, minus 5, minus 8, plus 7. We don't bother about all those values. Our concentration is wherever x terms present, concentrate there itself. So this is again f3 of x and it is equal to how much? Cos x. f4 of x and this is nothing but sin x, right? So individual functions we collected everywhere, and for these functions you need to find here periods. So what about here, students? Period of this function. The period is equal to how much? This period here, it is the individual value we are finding. The original function is sin x, right? It is of the form f of ax plus b. So period of f of ax plus b means it is nothing but period of f of x divided by x coefficient mod a. So basing on this, again we are using the period is nothing but here 2 pi. This is sin x period divided by the x coefficient is here 2. So 2 pi divided by 2, that is nothing but pi. And again here the period is equal to same value, that is 2 pi divided by 2. And this is directly cosine function. So direct cosine function means the period is here 2 pi. And next other value, here also direct sine, so 2 pi. So we got all individual periods, and to that now you have to find what? LCM. Okay, so period of the entire problem is nothing but, suppose if you take it as f of x is equal to LCM of all individual periods. What are they here? Pi, comma, again pi, comma, 2 pi, comma, 2 pi. Okay, so this is just our 180 degrees and this is our 360 degrees. Directly you can say it is nothing but 2 pi. So period of this function is nothing but how much? 2 pi. The meaning again, if you take the entire value as suppose f of x, right? The entire value, the problem you consider as f of x here, that is 2 sine 2x etc. whatever you are having, again in the denominator 7 cos x etc. Now you got period of the function how much here? 2 pi. That implies now if you replace x by x plus 2 pi, so x plus 2 pi wherever x terms are there, then you will get how much again? The same answer, right? In this way, wherever the x terms are there, replace them with x plus 2 pi. Okay, now if you multiply this value 2x plus 4 pi, so 4 pi plus 2x means it will be again in first quadrant, so you will get the value as 2 sine 2x. And again the other also, similarly 2 pi plus x implies 7 cos x etc. Then students, this is nothing but how much you got? It is f of x. So period of the function given problem is nothing but how much here? 2 pi. So content is what here? Wherever if you replace x value, whether they are 2x, 3x, whatever they are, if you replace x value by x plus 2 pi, the answer must be again the same old function, right? And next one, third problem, let us observe. What is the third problem here? That is tan 3 pi x divided by 4 minus 2 times secant pi x by 3 plus 5 sine 2 pi x divided by 5. So how to find here this period? Again same concept, that is individual periods. So let us observe here what is period of tan 3 pi x divided by 4. Okay, period of this value. Now what about here period, students? Actual period for tan is pi divided by the x coefficient is this value, right? The actual period of tan function pi divided by this one, that is 3 pi divided by 4. That implies what is this value? 4 by 3, right? And next one, period of the other function, that is secant pi x divided by 3. Again I am telling you, don't bother about here whatever the constants exist before the trigonometric functions. Always your concentration has to be only the trigonometric function, that's it. Now here secant pi x by 3. What about secant period? It is 2 pi. Therefore now 2 pi divided by, it is x coefficient, that x coefficient is here pi by 3. So this value, and now this is equal to how much here? 6, right? And next one, period of the third function sine 2 pi x divided by 5. So now again here the x coefficient is 2 pi by 5. And thereby this is 2 pi divided by 2 pi divided by 5. So what about this value here? 5. Now you found all individual periods. Now let us take here their LCM. So LCM of these values, that is 4 by 3, 6, 5. Got it? And now what about here denominators? These are 1. Now what about our formula, students? It is LCM of numerator values. So LCM of here numerators, that is 4, 6, 5. So LCM of numerator values divided by GCD of denominator. Denominator is 3, 1, 1. Now what about numerator LCM here? 4, 6 is there, 5 also there. So obviously we can say here 60, right? 60 if I take, then it will be here least common multiple. 30 won't satisfy because 4 is there. So 60. And what about in the denominator? The greatest common divisor is nothing but 1. Therefore students, what about here? Total period of this function is nothing but how much? 60. So observe here, everywhere you are getting integers, and these model problems they may ask even for which kind here, that is numerical integer problems. One problem we got 2 pi like that, but if at all you got this kind of answers, they may ask in terms of numerical integer type of problems. Okay, so I think you got these points whenever you are getting linear combination of trigonometric functions, how to obtain period. And next let us observe here this problem, one of the standard model problems, this one, that is a function is given here. Observe sin x into some unknown value and cos it is under root of b square plus 7 into x. So here what are our unknown values? Actually a and b are unknown values. Now this function is periodic with finite fundamental period. Then the question is, what is period of f of x? Now students observe here how are options actually. 3 options they gave independent of here, that is AB. Independent of AB, only one option given in terms of A and B. Now if I take here directly, that means they said already periodic. Understand? Periodic means LCM must exist. That is the concept. So 2 functions are there with plus symbol. That means linear combination of functions. Now whenever you come across with these kind of values, same old concept till now whatever we did, that is LCM of individual periods. So let us observe here LCM of, that means first period of which one here, sine of root of a square minus 3 and into how much it is, x, right? Now what about here period? Same concept, that is 2 pi sine function period divided by under root of a square minus 3. And next what is the other one? In the same way it is cos of root of b square plus 7 and into x, right? So this is the other value. Now for cos function also we write 2 pi divided by root of b square plus 7. So whether it is sine or cos, period we know original period is 2 pi divided by their x coefficients we wrote. Now what about here LCM? LCM of individual periods you have to take, that is 2 pi by root a square minus 3 comma 2 pi divided by root of b square plus 7, right students? Now what about here pi value? Pi is nothing but an irrational number. Now 2 irrational numbers when they are like surds, LCM exists. But when they are unlike surds, that means you got here 2 pi, but suppose denominator if I got root 7 and 2 pi, suppose you got here some root 11 value, then what about here LCM of these two? Understand? Maybe 2 pi it is the same, that means like value, whereas root 7, root 11 unlike surds. That means here LCM does not exist. When can we say LCM exists? If this number is P and if this number is Q, then if P by Q is rational, then we can say LCM always exists. But P by Q is not rational, it is an irrational number, so LCM does not exist. Then to make LCM to exist, what to do here? They gave clearly A and B are natural numbers. Understand? So whenever you got these kind of particular conditions while solving question paper, immediately underline, because sometimes in the hurry of solving these model problems we may miss this type of given data. That's why this is very very important to this problem. So A and B they are giving here positive integers, natural numbers. They are not zeros, they are positive integers. So once A and B are integers, let's make use of here the concept. What could be here? A and B values, so that LCM must exist. Because another condition they said the function is periodic, it must be periodic. Understand? That means LCM must exist. LCM must exist. A and B are natural numbers. Then using these two conditions you have to find here finally period. Now what kind of values can be here suitable? Observe students, a square minus 3 value. Understand, this value if I substitute, that means I must get here perfect square. and for what value you can get perfect square. So a square minus 3 can be a perfect square. For what values of a here? Obviously it is nothing but a equal to 2, right? When a is equal to 2, you can get here 4 minus 3, that is 1. So it will be a perfect square. Maybe some other values, but we want here fundamental period. Therefore whatever least possible you just can satisfy with those. And what about next here? Which value can satisfy? B square plus 7. If I put b as 1, then 7 plus 1 8, which is not perfect square. 2, then it is 11. 3, suppose 9 plus 7 16. Therefore it is a perfect square. In the same way, that is b square plus 7, to be a perfect square, b must be what here? 3. Then you will get 9 plus 7 16, and hence it is how much actually? Root of 16 means it is 4. Therefore students, finally what is our a value? We got 2 and b equal to 3. So when a is 2, what about here? Your denominator, it is 1. Therefore I am writing here, this is nothing but 2 pi, right, divided by 1. And what about here? 3, if you substitute, it is 9 plus 7 16, that means 4 you got. So 2 pi divided by 4. Now what is LCM of 2 pi comma pi by 2? That means 360 degrees comma 90 degrees. So obviously LCM of 90 and 360 is nothing but 360 degrees itself. Therefore what is our answer? 2 pi. So what are the major observations in this problem? Whenever they give a, b are integers or natural numbers etc., immediately just underline it. And after that they are telling the function must be periodic, implies LCM of these two numbers must exist. For that purpose the denominators must be here. Integer values are rational numbers. That means the value a square minus 3 b square plus 7 must be here perfect squares. As they are perfect squares and a and b are natural numbers and they require here fundamental period, right? Therefore we have taken a equal to 2 and b equal to 3. If you substitute, you got 2 pi, pi by 2, whose LCM is nothing but 2 pi. Therefore students, these kind of observations are very important while solving period problems. Okay. Now students, let us observe here product of functions. Till now whatever we have discussed basing on linear combination of functions, they may be in denominator or they may be in numerator, but nowhere we have observed about product of functions. What about here product of functions? Suppose I am taking here sin x into cos x, right? And now I can implement the same kind of concept, that is LCM of individual periods. So period of sin x into cos x we want to here. And whenever you want this kind of value, students, make here one clarification, that is period always you have to go for fundamental period. That means you can get directly by seeing any problem this is the period, but the requirement is always based on fundamental period. That means least among all possible periods you have to search always. Now here period easily you can say 2 pi, no doubt in that, because this period is here sin x individual period 2 pi, cos x individual period 2 pi, and if you take suppose LCM of 2 pi comma 2 pi, it is obviously 2 pi. Okay. So this function period is 2 pi, but what is our search actually? For fundamental period. That means still lesser value is possible or not. To that purpose, directly whenever any product exists, then not necessarily you have to use LCM, but as much as possible you have to go for the possibility of sum of two functions or difference of two functions. Okay. So now this is a known formula. What is the known formula from multiple and submultiple angles? It is nothing but half sine 2x. Now once it is half sine 2x, what about the period actually? The period is nothing but here 2 pi, the actual sine period divided by the x coefficient, that is 2, implies the value is here pi. That means 2 pi you got here, pi you got here, implies what is our conclusion, students? That means the fundamental period is here pi. That's why whenever product of functions exists, maximum to maximum extent you have to simplify it, and let's make use of here multiple submultiple angle formulae, or else you can make use of transformation formulae. Suppose they asked about here period of some sine 3x and into it is cos 2x, right? And earlier both are of same value, therefore we found actually the formula from multiple and submultiple angle. But here one is 3x, the other is 2x, so we can't write it as sine 2x theta formula. Now what about for this function, how to find period? Now you know about transformation problems, understand the name itself is transformation from product to sum or sum to a product. Now let's make use of that kind of concept here. So here what is our formula? Sin A cos B, but we must have here the number 2, and this is equal to sin of A plus B plus sin of A minus B. From transformation or compound angles we have this formula. Now students, this is your A and this value is our B, right? Now by making use of this formula you can obtain clearly it is half of, because there is no 2 here, half of sin of A plus B, that means 5x, and plus sin of A minus B, that is sin x, right? And now let's find here individual periods. What about here period of sin 5x? It is 2 pi divided by 5. And what about this period? It is 2 pi. Got it? What is 2 pi by 5? 2 into pi by 5 means what is the value actually? 36. 180 divided by 5. 36. That means this is 72 degrees and this one is here 360 degrees. So easily you can find here LCM. Immediately if you are unable to get this one, you can take here LCM of how much here? 2 pi by 5 comma how much? 2 pi, right? And now LCM of numerator 2 pi, GCD of denominator 1. So what is our answer, students? It is nothing but 2 pi. So whenever you got product of functions in this way, don't make use of the concept of LCM directly as it is. Convert this one as some linear combination, that means plus symbol or minus symbol. Then you can make use of again the previous concept, that is LCM of individual periods. Okay, now observe again the other problem, that is period of cos x and into cos 60 plus x cos 60 minus x. Of course you got the answer, this formula already we proved in multiple and submultiple angle. Individually don't take here periods, that is here 2 pi, 2 pi, 2 pi, don't take. Individually if you take, what is your answer? It is 2 pi. Understand, that is cos x period is, students, how much? 2 pi, and cos of 60 plus x period is how much here? X coefficient positive, it is 2 pi, and that value 60 minus x, even you can take here cos 60 minus x is the same as cos x minus 60, because cos of minus theta is nothing but how much? Cos theta. Therefore even you can write like this. Then what about here period? It is 2 pi. And now individually if you take period values, then you got how much? All 2 pi, and their LCM again 2 pi. But let us observe again whether it is true even if you got simplified value. What is the simplified value? It is nothing but 1 by 4 times cos 3x. Hope all of you remember this value. It is nothing but here 1 by 4 times cos 3x. Now we don't bother about whatever constants exist here. Our interest is only x coefficient. So what about here period of this one? Original period of cos function, it is 2 pi divided by the x coefficient is here 3. So you got 2 pi by 3, that means it is 120 degrees, right? Now students observe, directly if you got it is 2 pi, whereas if you do simplification then you got it as 2 pi by 3. So fundamental period, always your goal must be, your target must be here. What about here? Fundamental period, but not other period values. Because in options they gave 2 pi by 3 and they may give here 2 pi and they give here pi. Like this they used to give. then always your search you got 2 pi, okay, no doubt it is period, 100% right. But our search, I told you, it must be always about fundamental period. Still lesser values are possible or not, you have to check it, right? Now let us observe again the other problem, that is tan theta into 1 plus secant 2 theta, etc. I think this one also here we have proved already. What is the answer here? The problem we have done is actually tan theta into 1 plus secant, starting value itself is 2 theta, and into 1 plus secant 4 theta, etc. It is 1 plus secant 2 to the power of n theta, right? This one we have proved in the chapter multiple and submultiple angles. This answer we deduced as how much here? Tan 2 to the power of n theta, right? So this is the answer we got. That's why students, these kind of values you must remember, so that these will be useful in many other chapters also. Now as we know about the formula, directly I am making use here, that is tan 2 to the power of whatever here last term, the same term here also present. Now tan theta is there, 2 theta, 2 square theta, this is 2 cube theta, right? As it is 2 cube theta, therefore the answer is here tan 2 cube theta, that means tan 8 theta. So you have to simplify once any problem is given in terms of product of functions. The major observation is you must simplify it so as to get one simple answer or linear combination of functions. Now what about its period here? Period is nothing but the original period is here for tan function pi, divided by the x coefficient is how much here? 8. Therefore period of this function is pi divided by 8. Got it? And lastly, observe students, these are known as composite functions, which you can observe in the chapter function. What is a composite function? Understand? Now let us take here the first one as f of theta. Okay, it is a sine of pi sine theta. Now whenever this is theta, however the total problem is there, but always your concentration should go where is theta. Theta is here. However other functions we don't bother about them. This is our theta. So now here there is no particular formula for composite function. This is all just based on our observation of previous problems. Now what is the concept of periodicity? If you replace theta by theta plus t, you must get again original function. That means f of theta plus t, you have to get how much here? F of theta. Okay. So now here clearly sine theta, you know what is the value? 2 pi. That means f of 2 pi plus theta, if I write, it is sine of pi of sine into that is sine of 2 pi plus theta. And obviously you know students, it is nothing but how much again? It is sine of pi into how much? Sine theta. So you got how much here? F of theta. So these type of composite function problems, they just based on observation, that is whether 2 pi applicable or still lesser value possible. Now if I go for pi plus theta, you will get here how much? Minus sine theta, and sine of minus sine theta is nothing but minus sine theta, you will get minus f of theta. But according as our definition, you must get original function as it is. That's why here what is the final fundamental period? It is nothing but 2 pi. Okay. Now once cosine problems are there, you must be very cautious while doing cosine or secant, because of the danger point, that is cos of minus theta equal to how much? Cos theta, and at the same time secant of minus theta is equal to how much? Secant theta. Okay, so this is the major important point where you have to observe when a problem is in terms of cos like this, or it may be secant. If it is sine values, then not that much of danger, just one glance you have and thereby you can conclude your answer. Whereas these type of problems seems to be here 2 pi, no doubt. Cos x period is 2 pi, sin x period is 2 pi undoubtedly. But at the same time you have to search for lesser possible values. Suppose if I take instead of 2 pi, I am just observing pi. Understand? That is f of x is here cos of cos x and next value plus cos of sin x. Now what is my observation here? Whether it is a lesser value possible or not, that is f of pi plus x. Understand? Then what is cos 180 plus x? Cos 180 plus x is minus cos x and plus again cos of sin 180 plus x, it is minus sin x. So here is the danger point, students, that is basing on this cos of minus theta is nothing but cos theta, that is cos of cos x, and again cos of minus theta is cos theta, that is cos of sin x, right? And that implies this is our f of x. But again I don't want to satisfy with this value because of the reason cos and sin are complementary type of values. That is cos 90 plus x you will get minus sin, sin 90 plus x you will get cos. That is the reason pi okay it is, but still lesser value I want to search, that is nothing but pi by 2 plus x also I am going. Then what is cos 90 plus x? Cos 90 plus x is nothing but how much here? Minus sin x, right? And sin 90 plus x, that is nothing but here cos x. So you got here how much? Cos x. Wherever x is there, we replaced x value with pi by 2 plus x. Cos 90 plus x minus sin x, sin 90 plus x is cos x. Then again cos of minus theta, what is the value? Actually cos theta, that means you observe this value here, and again this is as it is, you can observe, that is nothing but how much here? F of x. So this kind of danger is there when cos of value present or secant present, at the same time complementary type, that means cos sin combination, tans again cot combination, secant cosec combination. So we cannot satisfy only with 2 pi, you must search for the lesser values also under only these kinds of functions. In the same way, students, observe here cos square of cos theta plus sin square of sin theta. So if you take this entire value as here f of theta, okay, then we observe here 2 pi, okay, that is no doubt you can get 2 pi, but my search is here pi also possible. So f of pi plus theta, if I write here, it is cos of cos pi plus theta and whole square, it is suitable for entire value. Similarly for sin also we write. Now what is cos 180 plus theta? It is minus cos theta. Again cos of minus cos theta is cos theta. Therefore you got here cos square of cos theta again. Now what about here sin of pi plus theta? What is sin pi plus theta? Actually it is nothing but minus sin theta. Then you got here sin of minus sin theta, right? And again sin of minus theta is there. Therefore you got this value is minus sin of sin theta whole square. Again whole square is saving, and thereby you got again the same old function, that means f of theta. So here what is the fundamental period, students? It is nothing but pi. But here you can't go for 90. If I write 90, this will become sin, this will become cos, which you can't get the original function. Got in this way, just a bit logic you have to use along with our concepts and formulae. Okay.